Good morning, friends. Session 56, Fisher's index number. Professor Irving Fisher considered applying geometric mean of both Laplace and the Pasteur's methods. He attempted to find an ideal index number as it confirms the tests of consistency and behavior. Earlier, what the methods which has been used for the index number? It has been denoted as the P01 price index number, which has been compared with the base year and the current year. In some index numbers, they have been ignored the quantities. In some, they have been ignored the geometric mean. So here the Fisher, who has applying the geometric mean, who considered the geometric mean, who considered the weightage for the individual importance has to be given for the both the commodities, all the commodities for that, and also he confirms that tests of consistency has been confirmed, satisfied. So that is why Fisher ideal index number, it is called as the Fisher ideal index number. It is an ideal index number when we compare with the other index number. He gives that the formula sigma P1 Q0, sigma P0 Q0, sigma P1 Q1 divided by sigma P0 Q1 into 100. Here P1 means current year prices, Q0 base year's quantities, base year's prices, base year's quantities, current year prices, current year quantity, base year prices has been multiplied with the current year quantity, so that we'll get the P01. If you multiply it with the 100, so that we'll get the P01. P01 means according to the Fisher's index number, price index number, you have to apply this formula so that we'll get the index number. Fisher index number is an ideal because it is based on appropriate average for index number, that is geometric mean. He used the geometric mean in order to get the index number. He considers both the quantities for the base year and the current year. In some previous, they have considered only the base year's quantities, but they ignored the current year quantities. But he considered both the base year and the current year quantity, and it satisfies the time reversal test and factor reversal test. Let us solve the problem so that we will understand what the Fisher he gives about the index number. Here base year's prices, current year prices is there, quantity, base year's quantity and current year quantity. Here base year prices has been assumed as the P0, base year's prices, current year prices has been assumed as the P1, then Q0, Q1, P0, 12, 10, 14, 16, 18, 20, 20, then 15. Then current year prices, it is the 20, 12, 15, 18, 20, 15, 16, 18. Then quantity for the base year 55, 100, 60, 30, 40, 70, 90, 80. Then quantity for the current year 120, 80, 80, 70, 40, 60, 100, 80. Then you have to get the here P1 Q0, P1 Q0, P0 Q0, then P1 Q1, P1 Q1, P0 Q1, P0 Q1. You have to multiply so that we'll get the total of the P1 Q0 and the 8470 and P0 Q0 8100, P1 Q1 10560, P0 Q1 9600. Now we have to substitute in the formula so that we'll get the P01. It is equal to square root of 8470 is the P1 Q0, then P0 Q0 8100 and P1 Q1 10560 and P0 Q1 9600 It is the square root of P01. P01 is equal to 1.04 into 1.11. If you divide 8470, we will get 8470 divided by 8100, 1.04. 10,560 divided by 9,600, 1.1. And if you multiply and remove the root and multiply it by 100, you will get the P01 as the 106. Here 106 is the P01 index number according to the Fisher's index number. He says that you have to apply the geometric mean for the given so that it is an appropriate measure of index number. So here P01 is equal to 106. Then whether it satisfies the time reversal test, we have to see here P01 into P10. P01. P01 means price index for the base year and the current year, and price index for the current year and base year. If you multiply, if the time has been reversed, if the current year prices has been put for the base year price and base year price has been put for the current year, you have, if you multiply, you have to get the 1. Then Fisher index number, it satisfies the time reversal test. Here 1 sigma p1 q0 sigma p0 q1 sigma p1 q1 sigma p0 q0 sigma p0 q0 sigma p1 q1. It has been reversed. In the place of the 0, you have been inserted as the 1 here. In the place of the 1, you have been inserted the 0, so that you will get the it is equal to 1. Here, if you simplify, you will get root 1 TRT is equal to 1. It satisfies the first time reversal test. The above problem, it satisfies. In the same way, factor reversal test P01 into Q01. Sigma P1 Q1 divided by sigma P0 Q0. If they, in the place of the prices, if you replace as the quantities, then in the place of P, Q, in the place of Q, P, in the place of P, it is the Q, in the place of the Q, it is the P. So here you have to get the sigma P1 Q1 divided by sigma P0 Q0. This is the test. Here we have been P1 Q0 is equal to 8470, P0 Q0 8100, P1 Q1 10560, P0 Q1 9600, Q1 P0 9600, Q0 P0 8100, Q1 P1 10560, Q0 P1 8470. If you remove the root, you will get 10,560 divided by 8,100. 8,100. Here 8,470 gets cancelled. And the remainder is 8,600, 8,470 and 9,600 gets cancelled. The remainder is 10,560 2 times, 8,100 2 times. It can be squared. And the square root and square gets cancelled. The remainder is 10,560, 8,100. Therefore, the above problem satisfies both the time reversal test and factor reversal test. In the second problem, here they are asking about Fisher's index number from the following data and show that how it satisfied TRT and FRT for the ABCDE products. Here PQ for the base year and the current year they have given. Now, if you multiply P1 Q0 P0 Q0 P1 Q1 P0 Q1, you will get 588, 462, 649, 514. If you substitute in the formula for the P01, the formula for the root of P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. 100 outside the square root. After getting the decimal points, you have to multiply it by 100. It has been expressed in the 100. That it is why it has been multiplied by 100. Then 588 divided by 462 into 649 divided by 514 into 100. So that you will get the 126. So this is the Fisher's index number. According to the Fisher's index number 126%. Then whether it satisfies the time reversal test, we have to see. The formula for the time reversal test, P01 into P10. P01 into P10, it is equal to 1. Now we have been substituted in the formula, so that 588, 649, 462, 514 in the numerators, 462, 514, 588, 649 in the denominator. Here 588 gets cancelled, 649 gets cancelled, 462 gets cancelled, 540 is cancelled. Everything in the root, it gets cancelled. The remainder is equal to 1. Square root of 1, it is equal to 1. Then we shall see in the same way factor reversal test. In the factor reversal test, P01 into Q01 is equal to sigma P1 Q1 divided by sigma P0 Q0. Here we have been reversed the factor. In the place of the P, Q has been replaced. In the place of the Q, we have been replaced the P. If we do in that way, we have to get the sigma P1 Q1, sigma P0 Q0. Let us see whether we will get it or not. Here 588, then 649, 512, 649, 462, 514, 462, 588. So here it satisfies both the time reversal test and the factor reversal test. Thank you.